Bad. A gazelle sprints from a cheetah. Its heart races, its breathing accelerates, blood rushes toward its muscles. Stress hormones flood its body, preparing it to survive. But if the gazelle escapes, something remarkable happens. The danger ends. Bad. Its nervous system begins calming down. It returns to feeding, resting, and living. You, however, have a problem the gazelle doesn't. Your cheetah may be a deadline, a bill, traffic, an argument, an unanswered message, a job you can't escape. Bad. And unlike a real predator, these threats can follow you for weeks, months, or even years. Your body keeps receiving the signal. The problem isn't stress itself. Stress is a survival system. Bad. The problem begins when that system keeps activating without enough time to recover. Because beneath your skin, chronic stress can influence your brain, cardiovascular system, immune system, digestion, and even processes happening inside your cells. Bad. And much of it can happen silently. Today, we're going inside that hidden biological storm. We'll uncover 3 major effects of chronic stress. How prolonged stress can alter the brain's threat system. How stress is connected to cellular aging. Bad. And how long-term stress can disrupt the body's systems of defense and recovery. This isn't simply about feeling overwhelmed. It's about what happens when an ancient survival system meets a modern world that rarely tells it when to stop. Bad. When your brain detects danger, your body reacts before you have time to analyze everything. Your adrenal glands release hormones including adrenaline and cortisol. Your heart rate rises, your breathing changes, your attention becomes focused. Bad. Your body shifts resources toward dealing with the threat. For a short emergency, this response can save your life. But your brain doesn't only respond to physical predators. It can also respond to uncertainty, financial pressure, social conflict, bad, work problems, and fear about the future. And these modern threats often don't have a clear ending. That's where the problem begins. Repeated or prolonged activation of the stress response can gradually affect multiple systems throughout the body. Bad. And the first place we need to look is the command center, your brain. 2 important structures in the brain are the amygdala and hippocampus. The amygdala is involved in detecting and responding to threats. Bad. The hippocampus plays an important role in memory, learning, and regulation of the stress response. Under normal conditions, these systems work together. A threat appears, the alarm activates, the danger passes, the body begins returning toward normal. Bad. But chronic stress can disturb this balance. Research suggests prolonged stress can affect neural connections and alter activity in brain regions involved in fear, memory, and emotional regulation. The amygdala can become more reactive, bad, while chronic stress can interfere with functions involving the hippocampus and prefrontal regions. This can create a feedback loop. The brain becomes more sensitive to potential threats, while regulating those reactions becomes more difficult. Bad. And this isn't simply about becoming too emotional. Your brain is adapting to the environment it believes you're living in. If the message is constantly, your brain can begin acting accordingly. And the effects don't necessarily stop inside your skull. Bad. Because stress can reach all the way down to the level of your cells. Inside your cells are chromosomes carrying your genetic information. At the ends of those chromosomes are protective structures called telomeres. Bad. Think of them like the plastic tips on shoelaces. They help protect the ends of chromosomes. Telomeres naturally change and generally shorten as cells divide, and their length is influenced by age, genetics, and many environmental factors. Bad. Researchers have also investigated the relationship between chronic psychological stress and telomere length in research involving caregivers experiencing significant chronic stress. Higher perceived stress was associated with shorter telomeres. Bad. The finding was fascinating because it suggested that psychological stress may be connected to measurable biological processes associated with cellular aging. But there's an important distinction. Bad. This does not mean that one stressful day suddenly ages your cells by years. And it doesn't prove that stress alone determines how quickly you age. Human biology is far more complicated, but the connection is still important. Bad. Your mental environment can interact with your physical biology. Your brain communicates with your hormones communicate with your organs, and those signals can influence processes happening inside your cells. Bad. But there's another system that feels the effects of chronic stress in a very different way, your cardiovascular system. Imagine your body preparing to run from danger. Your heart beats faster, your blood pressure rises, your circulation changes, your body is preparing for action. For a short emergency, that's useful. Bad. But when the stress response is activated repeatedly over long periods, the cardiovascular system can be placed under additional strain. Chronic stress is associated with factors such as elevated blood pressure and can interact with other cardiovascular risks, bad, including poor sleep, inactivity, smoking, and unhealthy eating. Stress doesn't simply create heart disease by itself. Cardiovascular disease is complicated, but chronic stress can become one part of a much larger risk picture, bad. And the danger isn't necessarily one stressful meeting, it's the pattern. Stress, poor sleep, less exercise, poorer food choices, and never enough recovery. Over time, these factors can reinforce one another, bad. And while your heart is dealing with that pressure, another major system is also responding. Your immune system. Your immune system is not simply an on and off switch, it's a constantly changing network of cells and chemical signals, bad. Short-term stress can temporarily alter immune activity in ways that may help the body respond to an immediate challenge. But chronic stress is different. Long-term stress can interfere with immune regulation and inflammatory processes, bad. This is another example of an ancient system being pushed beyond the situation it evolved to handle. Your body was designed for bursts of danger, followed by recovery. Modern life can create repeated stress without a clear recovery period, bad. And your digestive system can feel this too. When you're under intense stress, digestion isn't your body's highest priority. Your nervous system can change how your digestive tract moves and functions. That's why stress can sometimes cause a tight stomach, bad, changes in appetite, nausea, digestive discomfort, and chronic stress can influence the complicated communication between your brain, gut, immune system, and gut microbiome. This connection is often called the gut-brain axis, bad. Your brain and digestive system are constantly communicating, so stress isn't simply something happening in your head. Your body can feel it, but here's the part many people forget. Stress isn't always harmful. Your body actually needs challenges, bad. Exercise temporarily stresses your muscles. Learning challenges your brain. Brief exposure to controlled challenges can stimulate adaptive responses. This idea is known as hormesis, bad. A manageable challenge followed by recovery can make the body better prepared for future challenges. Exercise is a perfect example. You stress your muscles, your body repairs them. And over time, they become stronger. The critical difference is recovery, bad. A challenge followed by recovery can produce adaptation. A challenge without recovery can become a problem. That's why the goal isn't to eliminate every stressful experience from your life. That's impossible, bad. The goal is to give your body enough time to switch out of survival mode, because recovery isn't weakness. Recovery is part of adaptation. Modern life has created something evolution never prepared us for, a world where the threat can follow you home, bad. You can finish work and still think about work, put your phone down and still receive another notification, get into bed and replay tomorrow's problems. Your body may be sitting still, but your biology may still be preparing for battle, bad. And that's why chronic stress deserves attention, not because every stressful moment is secretly destroying you, not because stress automatically causes disease, bad, but because repeated stress without enough recovery can influence the systems that keep you functioning: your brain, your heart, your immune system, your digestive system, and your cells. The good news is that your biology can adapt in both directions, bad. Better sleep, regular movement, healthy routines, social connection, and periods of genuine recovery can all help create a different signal. Your body doesn't need a life without stress. It needs a life where stress is followed by recovery, bad. Because sometimes the most powerful thing you can do for your health is simply give your body permission to stand down. And if you want to discover what happens when recovery disappears completely, watch our next video.